followed by a detector, and then a low pass filter. And finally, when you did the FM modulation, did you perform the FM modulation? Huh?
Yes,
है ना?
sir.
So finally you observed your received signal here, है ना? In the FM modulation experiment. Now today what you have to do, you have to provide the noise to the system, okay? And then you have to observe what is the effect of the noise on the received signal, okay? Now first, for that purpose, we will first of all check the message signal, है ना? We will first of all generate the message signal that we want to modulate, है ना? That we want to send out using the frequency modulation. Okay. Now this is the message signal. Note its frequency and its amplitude. Okay. After that, you will check whether the reactance modulator does the modulation process or not. Okay. So you will check the modulated or the frequency modulated signal here, as you did in the FM case. है ना? See. So now if you check, frequency modulation is happening, है ना? है ना? There are compressions and reaffection, है ना? So frequency modulation is happening, huh? ठीक है? After getting the frequency modulated signal, what you will do, you will first of all check whether you will receive the given message signal at the receiver or not. Okay. In order to check whether the FM system is working or not. Okay. First of all, you will check, just for purpose of checking. You will do this, connect it here, and see you have received the signal. है ना? You have received the signal. See the frequency also match. Frequencies of both match. है ना? So the message signal that you are transmitting is being received. So this kit is working completely. है ना? Up till now. Now what we will do, we will see the effect of the noise on this circuit. Okay? Just bring one more probe.
जुड़ा हुआ है कि नहीं वहाँ से जोड़ना पड़ेगा।
Bring a banana cake. तुम बताया इसको? पता चल जाएगा तुम लोगों को एग्जाम में, ठीक है? पता ही नहीं है तुम लोगों को बनाना की लब्बी क्या होती है। जिसको घूमने देना था ढूंढता रहता है बनाना क्लिप वहाँ पे। ओके, सो नाउ आई एम adding some noise to the signal, okay, to the FM signal through this input, and here is a mixer, so I am adding some noise to this signal. Okay, now the noise voltage and the frequency has to be kept constant, that I have written there. It is 2 kilohertz, okay, and sinusoidal signal 2 kilohertz, and amplitude should be 200 millivolts. Okay, now after this we will check what is happening to the received signal. Okay, when we are adding noise, now we will check what is happening to the received signal. And this is the received signal, है ना? First of all, you have to again check the noise, क्योंकि क्या होता है कभी कभी you know that you may not have selected the correct channel, है ना? So first of all check the noise for that purpose here. see if I vary, is it varying? So I have not selected the correct channel, huh? So I will select first of all the correct channel. Now now see, this is the frequency and the amplitude of the noise that I am doing. 2 kilohertz थोड़ा वेरी हो रहा है, फ्लक्चुएट कर रहा है, आना चाहिए इतना ही. इट शुड बी 2 kilohertz and 200 millivolts ना, थोड़ी सी ज़्यादा हो रही है. मे बी दिस काजिंग सम एटेन्यूएशन दिस प्रो. हम यहाँ पे देख लेते हैं, बेटर है हम यहाँ पे देख लेंगे, बेटर है हम यहाँ पे देख लेते हैं. ठीक है. So it is 2 kilohertz and around 200 millivolt है ना, 280 है ना, ठीक है. Now the same signal is being provided to this circuit है ना, noise signal. Now we will see the effect of the noise on the received signal. See what happened to the received signal. Okay, what's happening to it? There is a sometimes there is a constructive interference and sometimes destructive interference. Okay, so sometimes the amplitude is increasing and sometimes it is decreasing. Okay. Now if you take the mean amplitude of this signal, okay, it peak to peak mean amplitude, it comes out to be around 1.445 volts है ना, जितना यहाँ पे दिखा रहा है. ठीक है. So this amplitude is the amplitude of the signal added with noise. Okay, है ना.
Yes.
Now when I use the amplitude limiter, now the amplitude limiter filters out the noise. Okay. Now what would be there? Now there would be only the sinusoidal signal that I am transmitting, the same signal will be received because the noise has been filtered out by this amplitude limiter. Okay. So now the voltage here is the signal voltage, है ना, signal voltage only, output at the output. Now in the initial case we had signal plus noise voltage, and now we only have the signal voltage. So when we will subtract, we will obtain the noise voltage at the output, है ना. We already know the signal voltage अभी जो है ना. Then we will take the ratio of them to find the signal to noise ratio at the output. Okay, and initially we also know the signal voltage that we are giving, वो ये है. Okay, and we also know the noise that is fixed at 200 millivolt peak to peak, है ना. So initially we know the signal voltage as well as the noise voltage. So we will take the ratio of that and find the signal to noise ratio at the input. Then using the formula 20 log base 10 that is written there, you will find the noise figure by taking the ratio of both the values that you have got, SNR input by SNR output. Okay, so this is today's experiment. Okay, you can also do one more thing in this experiment, that is you can check after calculating the SNR. In order to take other readings, you will change the amplitude and the frequency. Maybe for one reading you will first change the frequency, then for other you change the amplitude and see the effect of the noise on the same signal, or change the frequencies in all the cases. Okay, see the effect of the same on the of the noise on the signal. Okay, or you can also, or else this is for reading purposes, taking the readings, and for each of the changes you have to calculate the noise figure. Okay, also you can do one more thing. You can also change your detectors. Okay, for example, I have used a quadrature detector for this pattern. Now I will see the effect of the noise in detuned resonant circuit. Okay, then I can by this I can verify which of the detectors is most affected by noise. Okay, this is for visualize, in order to make you understand about the detector. See, this Foster Sally detector is very less affected by noise, है ना. This is the property of a Foster. It's a very good detector. See, ratio detector here, it is very less affected by noise, है ना. देखा. Now if you select the phase lock loop detector, क्योंकि ये तो उससे भी कम ही affected by noise होता है, क्योंकि ये ना select is the signal back. Okay, it itself rejects the noise and selects the signal back, so it is very less. किसमें? हाँ, ये इसलिए होता है लेस में फेज लॉक लूप डिटेक्टर में. पता है क्यों? क्योंकि ये ना it works like the RF amplifier of the receiver circuit. Okay, there is a voltage controlled oscillator here. जिसकी फ्रीक्वेंसी वैरी होती है. ओके, सो इट द फ्रीक्वेंसी ऑफ दैट वोल्टेज कंट्रोलर व्हेन इट वैरीज एंड इट बिकम्स इक्वल टू द फ्रीक्वेंसी ऑफ द मैसेज सिग्नल दैट इज बीइंग सेंट. जब हम एडजस्ट कर पाते हैं, सो देन इट रिसीव्स द सिग्नल, अदरवाइज इट रिजेक्ट्स ऑल द थिंग्स. सो इसमें बहुत कम इफेक्ट होता है नॉइज़ का. ओके, इसमें बस क्लिपिंग हो जाएगी क्योंकि आपने शायद ये ना दिस यू हैव गिवन मोर ऑफ द एम्पलीट्यूड. ओके, ओके, so you can verify which of the detectors works the best also. Okay, और बस हाँ, ये दो चीज़ें आप कर लो इस एक्सपेरिमेंट में. फर्स्ट ऑफ ऑल यू विल डू कैलकुलेट द नॉइज फिगर, then you can vary the frequency or the amplitude and calculate the noise figure and take 2 to 3 or 4 readings, and correspondingly after that you will check the working of each of the detectors. Also there is one more thing, you can also change the modulator and see its effect. What is the effect of utilizing different modulators? Okay, okay, okay. So go to your tables and perform the experiment. Does anyone have any doubts? Doubt है किसी को?